Hello friends, I welcome you to my YouTube channel MacPM. So in this video we will solve a numerical problem which is based on the metacentric height, and after calculating the metacentric height we will see if this cylinder which is floating in the water is it stable or it is unstable. Okay, so let's read the problem first. A solid cylinder of 10 centimeter diameter and 40 centimeter long. So diameter D. We will note the important parameters to solve this question. D is equal to D is equal to 10 centimeter and L is equal to 40 centimeter. Consists of two parts made of two different materials. The first part at the base is 1 centimeter long. So this is first part and this is second part. This is only 1 centimeter long. Okay, so L1 is equal to 1 centimeter. L2 is equal to, this total is 40, so 40 minus 1 is equal to 39 centimeter. This is L2. And the specific gravity of 1 is equal to 6, and other part of the cylinder made of material of specific gravity, so specific gravity is 0.6 of this two part, second part. If it can float vertically in water, so we have to find we have to calculate if this cylinder can float vertically in water or it will fall down. Okay, so let's see. So what is specific gravity? Specific gravity is density of material divided by density of water. So density of material rho m is specific gravity into density of water. So what is density of water? It is 1000. Okay, so Sg1 is 6. So rho 1 is 6 specific gravity into density of water, which is 1000 kg per meter cube. It will become 6000 kg per meter cube. Similarly, rho 2 will become 0.6 into 1000, which will be equal to 600 kg per meter cube. Now there are two parts, part 1, part 2. So what will be the center of gravity? Center of gravity is the whole part. So suppose center of gravity of first part is G1 and center of gravity of second part is G2. Then G, center of gravity G of the whole cylinder is W1 G1 plus W2 G2 divided by W1 plus W2, where W and W2 are weight of the part 1 and part 2, and G1 and G2 are the center of gravity of part 1 and part 2. So suppose we are taking center of gravity from point A. Okay, so what will be the weight of part 1? W1 will be equal to, see, this area is pi by 4 d square into length is 1 centimeter. 1 centimeter into this is volume, and density is 6000 kg per meter cube. So if density you are keeping in meter, then this one should also be kept in meter. So this is 1 centimeter, means 1 by 100 meter into this is pi by 4 d square L into A divided by 100. This is volume into density is, for first part it is 6000 into G 9.81, and W2. So if we will calculate it, then we will become pi by 4 into diameter of the cylinder is given as 10 centimeter. 10 centimeter means 0.1 meter into this L is 0.01 into 6000 into 9.81. Similarly W2 for second part is pi by 4, D is same into L is 39 centimeter now, so 0.39 into density is 600 into G is 9.81. so we will keep these values here. So center of gravity of the whole cylinder is W1, which is pi by 4 D square 0.1 square into L 0.01 into density 6000 into 9.81. okay, so this is weight into center of gravity G1. G1 is half of the height, so height was 1 centimeter, so half of the height is 0.5 centimeter, which is 0.005. okay, plus W2 is pi by 4 D square, D is 0.1 into L is 0.39 plus pi by 4 D square into density is 600 into 9.81 into pi by 4 D square L into G into the G2 is, this is 39 centimeter. okay, total height. So what will be center of gravity of the second portion? It will become 39 1 plus 39 by 2 divided by 100. This is in centimeter. okay, why this? Because 1 centimeter is already here plus half of this height. okay, so divided by W1 plus W2, so W1 is this, W2 is this, so W1 plus W2. so if you can cancel pi by 4 D square, everything, it is common in all the parts. So if you put the W1 and W2 here and if you calculate it, then you will get center of gravity G is equal to 16.42 centimeter. okay, or 0.1642 meter. so this is center of gravity of the whole cylinder. Now this is the diagram, let's put it here. Now this was the diagram. Now this cylinder is floating in the water, so its weight will be equal to volume displaced by water. So what is the weight of the cylinder? Weight of the cylinder we have already calculated, pi by 4 D square is 0.1 square, 0.1 square into 1 divided by 100 into 6000 into 9.81 plus W2 pi by 4 D is 0.1 square into 0.39, this is L or H into 600 density into 9.81. so this is total weight of the cylinder. This will be equal to volume of water displaced. So pi by 4 0.1 square. So suppose height of cylinder which is H up to here, it is submerged in water. So S is the height of cylinder submerged in water. okay, so pi by 4.1 square into H by 100, suppose it is H in centimeter, that's why we have divided by 100 into 1000 is the density of water into 9.81 is acceleration due to gravity. So if you will calculate it, then you will get h is equal to 29.4 centimeter. So we have found the value of h. Now what will be the center of buoyancy? Center of buoyancy will be half of the height of displaced water or half of the submerged cylinder. So it will become half into 29.4. So it will become 14.7 centimeter. Now formula for metacentric height GM is equal to I by V bar minus BG. Okay, so I for this is cylindrical circular cross section, pi by 64 d to the power 4 is equal to pi by 64 into diameter is 0.1 to the power 4. Okay, and volume of cylinder in water, is equal to, if you see here, if you put the value of h is equal to 29.4 here, then it will become volume of water. Okay, so if we put value of I here, pi by 64 into 0.1 to the power 4 divided by V is pi by 4 d square into 0.294. This is volume of water. So it will become minus Bg. So what is Bg? Distance between metacentric height and center of gravity. So it is 16.42 and this one is 14.7. So 16.42 minus 14.7. So it will become 0.212 minus 1.72. If you calculate, you will get minus 1.508 centimeter. Sorry, this is divided by 100 because this was in centimeter, and this will be also in centimeter. In meter, we divide by 100, so it will become minus 0.001508 meter, or sorry, it will become minus 0.1508 meter, 0.0158 meter. So it will become equal to 1.508 centimeter. So this is negative. If you can see, this is negative. So if this is negative, means meta center is below center of gravity. So if meta center is below center of gravity, this is unstable situation. So this cylinder will be in a unstable position and it will fall down. It cannot float like this in a vertical position. So due to instability, if we just touch it little bit, then it will fall down. Okay, so I hope you understood this problem. If you have any doubt, then you can ask in the comment section, and thank you for watching.